In this video, we are going to discuss relations and functions. We are going to begin by defining what a relation is, and then we are going to give two examples. A relation is a set of points connecting two variables. So let me write this here. So to give our first example, we need to define two sets of variables. Call this one example 1. And these are going to be my variables. I'm going to have a set S for the variable small s. That is going to be the pre-IB students at our school. So S such that S is a pre-IB student. You may know that that set has 63 elements, so we can write cardinal of S with this notation or even with this notation. There are 63 elements in that set, and that's going to be one of my variables. The other set has only 2 elements, and they're going to be the T elements, the T variable, and they're going to be the math teachers at our school. So it's Sune and Laura. So in this case, we have a set with only 2 elements. And I'm going to define a relationship between those two variables. And I'm going to use a picture for that. So I'm going to use a set of axes. I'm going to sketch the S values in the horizontal axis and the T values in the vertical one. So I will start by the vertical because it's shorter. So we have Sune and Laura. And then here in the horizontal S, we have really a lot of points over here. We have 63 of them. I'm not drawing all of them, ... to symbolize that there are many. And I'm not going to write the names of the 63 pre-IB students from our school. But the first relationship that I'm going to consider is going to be the following. S is in T's class. So I'm going to write pairs ST, where S is going to be a pre-IB student and T is their teacher. So we are going to have many points for this relation. For each of the 63 points we have in the horizontal axis, we are going to have to decide if we have a point at the Sune level or we have a point at the Laura level, depending on who is the teacher. So for instance, I'll give you some examples of the points in this relationship. We have the point Emma, Laura. We have the point Mark, Sune. We have the point Nadia, Sune. And we have the point Prem, Laura. And well, there are 63 such points, so we are not going to mention all of them. But this is our first example of a relation. We have a set of points connecting two variables, and the relationship is S is a student and T is the math teacher of that student. Let's move on to example number 2. In this example, the relation is going to be T is S's teacher. So now, if we try to sketch this, I'm going to use axes again. I'm going to have the T values in the x-axis. So we're going to have Sune and Laura. And then we are going to have the 63 points with all the students in the vertical axis that usually we call Y. So for instance, we are going to have dots like, for instance, let's say this dot over here could be Sune Nadia, because Sune is Nadia's teacher. Or it could be another point over here, Sune Mark, because Sune is Mark's teacher. And with the same examples as before, we can have the point Laura, Emma, and also the point Laura, Prem, because Laura is Emma's and Prem's teacher. So let's see what is different between the two examples that we consider. And I'm going to add a little bit of notation over here. We are going to call, let's say we have the relationship x has point x, y, so x is related to y, those are the two variables. We are going to call the first set, the points of the first set, the points of the domain, and the points of the second set, the points of the range. So with this notation in example 1, the domain was the set of students and the range was the set of teachers, of math teachers. And example 2 is the other way. The domain is over here, is the set of teachers. This is the domain. And the range is over here in the vertical axis, is the students have the range. So we want to define a special type of relation that we call function. And what is special about this relation is that we cannot have two pairs that are different, but the first member is the same. So we cannot have pairs, let's say x, y, and x tilde, y tilde, that are different, but x is equal to x tilde. So once we fix one value x in the domain, then there is only one value y in the range that can go with it to form a pair. And we can clearly see here that in example 2, we do not have a function because we have a teacher, Sune, who has, for instance, in the class, Nadia and Mark and 18 other students. So there will be 20 pairs that start with Sune, but then they have something different in the range. And that is what we do not want to happen when we want to study functions. So let's go back for 1 second to the example we had as example 1. Scrolling up here. So in example 1, each time you have a student, the student has only one math teacher. So for instance, if you pick the student Emma, then Emma is in Laura's class, so Emma Laura is going to be the only pair that starts with Emma in the first place. So example 1 is a function, while example 2 is a relation that is not a function. And what we are going to study now is actually functions. I wrote over here the definition. A function is a relation where no different pairs can have the same first element. And I'm going to give 3 more examples. And those examples come from things that you have studied before. So we are going to look at lines. So the first example we are going to consider, and now we are also reviewing some notation that we know and that is actually called function notation. I'm going to say f of x is equal to 2x minus 1. We know that this represents a linear function, and maybe before you wrote it as y is equal to 2x minus 1. And we can even sketch how this is going to look like. So we can draw a graph for this function. Well, I'm saying it's a function we are going to check. For sure it's a relation because for each value of x, we can correspond the value of 2x minus 1. So it is a relation and we want to check that it's a function. So let's sketch it. So first of all, we know that the y-intercept is at minus 1, negative 1 over here. So that's 1 point in the y-axis is 1 point of our line. And then the gradient or slope is 2, which means that each time I move 1 step forward, I need to move 2 steps up. So I will arrive to the point 1, 1. So I need a ruler over here. I'm going to draw the line. A bit far. Okay, it's not perfect, but this is my line y equals 2x minus 1. So this is one way of representing this relation. And we can see that it is actually a function because we can see in the picture that there are no values of x that have two corresponding values of y. Any value of x that we pick, for instance, a value of x over here, we apply the relation 2x minus 1 and we arrive to one value of y given by 2x minus 1, and there is no other option. So this is a function. Next example, I'm going to also consider line. I'm going to consider the line f of x is equal to 3. So let's sketch this line now. Well, the y-intercept is 3. So let's say it's over here. That's the point of the line. And then we don't have any term with x, which means the gradient is 0. So actually the slope is 0. So actually over here, where we are talking about is a horizontal line. So I'm going to sketch the horizontal line here. So I'm going to draw my line over here. This line represents the function f of x is equal to 3. And we can see also in this case that for each value of x, there is a unique corresponding value of y, namely the value 3. So this one over here is also a function. So you may be thinking at this point, well, looks like all lines are functions, and that's why we have example number 3 over here. And in this case, my example is going to be x is equal to -2. So let's sketch how this looks like. I have my axis over here. I have the point, let's say -2 is over here. And then, well, what is the relation here? I'm saying that x is -2, and then I'm not saying anything about y. Actually, y can be anything. This is a vertical line. So let me sketch it over here. Okay, it's not as straight as I would like, but let's pretend it is. So this is x is equal to -2. This is a line, but this is not a function. So vertical lines are examples of relations that are not functions. So we have over here 3 examples. 2 of them are functions and the third one is not.